at it, everything's a gift from God. So.
Well, this is true. But not everyone receives it. Let's see here. I will begin with a word of prayer. Heavenly Father, we thank you for this day. Again, I thank you for this class and this time we have to meet and study your creation. Help us to glorify you and what we do, Lord. In your name I pray, Lord Jesus. Amen. All right, so first things first, let me show you the solution to the quiz. Here it be. So, the Laplace transform of the direct delta function is e to the minus s, because I got this minus 1 here, right? This thing, Laplace transforms to s squared minus s, because I've got the 1 here, minus 2, because I've got the 2 here, 6 times s times big Y, minus the 1, because the initial condition's 1, and then plus your 45y. And then solve for big Y, you get this. And complete the square in the denominator. We've got an s plus 3 squared plus 36. So I want to create an s plus 3 and a 6 upstairs to anticipate the inverse transforms of cosine and sine respective as I do down here. So inverse transform of this piece is that. The inverse transform of the 5/6 piece is this. E to the minus 3t because of the shift by plus 3. Sine 6t because this 36 is 6 squared. And then over here, I've got what's in the front, the inverse transform of that, big F of s, you could say is little f of t equals to 1/6 sine 1/6 e to the minus 3t sine 6t. So by the theorem, I have to replace the t with t minus 1 and multiply by the unit step function to reflect the presence of this guy right here. Of course, this is the solution that's a response to the initial conditions which are given. And then this over here is what the system does as a response to turning on, whacking it with a hammer, so to speak, at time 1. So that's it. Now, problem 2 is really just a straight, application of the unit step identity with the exponential, whatever you want to call this thing. I don't even have a name for it, but how do you take the inverse transform of an exponential minus 3s times 1 minus 1 over 1 s minus 7 squared? Well, I just, here's a couple things. So the Laplace transform of t is that, which means the inverse Laplace transform of 1 over s squared is t, but if I have s minus 7, that ends up multiplying by e to the 7t. Of course, you could just find this directly on the sheet if you wanted to. I just sometimes like to look at some of the, progression of ideas. This is, of course, not necessary. You could jump straight to here. In fact, you could jump straight to here, really. So the Laplace transform e to the minus 3s times f of s is f of t minus 3. In this case, the f of t is t, so t minus 3, and then times u of t minus 3. What? Why is there? Oh, yeah, that's right, because there's an e to the 7t here. I'm an idiot. I forgot. But the t gets replaced with t minus 3. So listen to what I wrote, not what I said. Yeah. Questions? No comments? No comments allowed. Only interested in questions. That looks like a comment. What is it? Was it a question?
Could you please, perchance, go back up to the first one? So is the u of t minus 1, is that coming from the e to the negative s?
Yes. So on the sheet, and just you guys keep asking me, but let me say it again. You are allowed to bring this sheet to the test, and you may also write whatever you like on the back, and even between the formulas if you wish. All right. So, and if any of these ones is too fuzzified for you to read, by all means rewrite it so that you can read it. Yeah.
Sorry, I have a really small question. Are you wanting to give us another sheet of that, or should we stick with
You stick with the one I gave you. Yeah, I'm not giving you another one. What?
Shouldn't the last sign be 6?
Oh man, what are you talking about?
Sine 6t minus 1.
Oh, what have I done?
Isn't that 3?
Oh yeah, definitely. My bad. Thank you. I'll allow that comment as it's constructive. Although the spirit behind it, not entirely, I don't know. So trying to read into it, but yes, that's supposed to be a 6 times t minus 1 here, right? The 3 goes with the s plus 3, but this is 6 squared. So I'm supposed to put a 6 here, like I did here and here, but apparently I, make mistakes. So. What?
Giving us attendance again.
Did you guys already do this?
Yeah.
Yeah.
Oh. Anybody miss it? See? There we go. Served a purpose. Well, you hand it back. There's someone behind you. Just hand it back.
Oh, well, I looked back there and everyone said no.
So you guys just work around him. Like that's low. You're surrounded by enemies. All right. Are we good? So my apologies. I do not have the whatchamacallit, the solution to the Team Mission 3 scanned yet, but I should have that sometime today. All right. So in the meantime, do you guys have? Well, I'm going to work this example and then I'll ask if there are questions. Let's work this example here.
We just work through the problems like together as a team.
We don't have 10 hours.
like just one problem.
We can do this one. So.
Jordan had a problem in particular he wanted to ask about.
I second that idea.
But
You third that.
this feels like a trap.
Well, me and Jordan.
Which problem are we talking about?
49?
Oh, yeah.
Which?
Quadratic.
Max, you
Sure.
You say.
I will consider your request. Give me a second here, see if I want to get into this.
Yeah, can I get a seventh on that?
Yeah, raise your hand. You guys have like an 8. 8?
49? Really? This one?
That was the goofy one.
Oh, yeah, we'll do that. We'll do that one next. Fine. So let's solve this here. All right. So I'll do number 49 next. I think we have time. Should be fine. Okay. So, whoa. I thought my phone said 3:38 for a second. I was like, what? Is this a dream? Like, what's going on? But so how do you solve this? By the method of Laplace transforms. See, you maybe know how to solve this using eigenvectors, right? Some of you more than others. But there's another way we can use Laplace transforms. Let's see how that goes. We take the Laplace transform of each, and how's that go? So like, what's the Laplace transform? See, when I was taking differential equations, I don't know, I personally thought this was really cool. So I wanted to show it to you guys. It's definitely a competitor for the 2x2 problem. It's about the same efficiency as the eigenvector method. So here we get s times big X, right? And minus x of 0, which is 1, right? And the Laplace transforms of dy dt is s times big Y minus the plus 1, because the initial condition is 1 here. On the other hand, that's equal to the Laplace transform of 2x plus y, which is what? Bless you. No. 2x plus y. And x plus 2y. Right? And then how do you solve these? What do you got? You got 2 equations and 2 unknowns, so solve it. Yeah, so like put everything together. So we've got a 2 minus s times big X plus y equals to minus 1. And we've got a, let's see here, minus x. Oh man, I'm sorry. We've got x plus 2 minus s times big Y equals to 1. So I moved all the x's and y's to the right-hand side, and then I flipped it. So if I've got two equations and two unknowns, and it isn't like super obvious, like, okay, so how do you guys want to solve this? We could use the matrix technique, we could use substitution. Student's choice, what do you want? Substitution, so boring. All right, so x equal to 1 plus s minus 2 times y. Notice that I flipped the subtraction on the other side to absorb the minus. And then we take that and we plug this contraption right here up into there, right? And that gives me 2 minus s times 1 plus s minus 2 times big Y, right? Plus big Y equals to minus 1. Which gives me 2 minus s times s minus 2 plus 1 times big Y equal to minus 1 minus parentheses 2 minus s. Which gives me big Y is equal to, I guess we could simplify that a bit. What is this? S minus 3. So we've got s minus 3 divided by the thing in the square brackets, which I'm going to multiply out now. That's minus s squared minus 1. Oh, let's see here. I gotta be careful. How many s's? 2, 4s plus 4s. Minus 4 plus 1. Minus 4 plus 1, also known as minus 3. Thank you. And hey, this is traditionally where I make the mistake if I'm going to make it. So let's put the minus upstairs. I'll get 3 minus s over s squared minus 4s plus 3, right? Now we'd like to take the inverse transform of that, but what should we do first? How do we take the inverse transform of 3 minus s over s squared minus 4s plus 3? What should we do? Complete the square. We could do that, but there's an easier way here. So factor it. Yeah, this factor. How's this factor? Yeah, s minus 3 times s minus 1. All right. So we want to do a over s minus 1 plus b over s minus 3. That brings me to
I was going to say if the s squared term was negative.
You should make it negative as you can.
Yeah, I see
I absorbed the minus up in the numerator.
that. I missed that. I just saw it right after.
Yeah, it's cool. So we have 3 minus s is equal to a times s. I do make mistakes, so speak up. It's fine. And then what we got? Put s equals to 1. Put s equals to 3. What do we get? S equals to 1 gives me 3 minus 1 is 2. Equal to what? 1 minus 3 is minus 2a. And s equals to 3 gives me 0. Oh, this is dumb.
You just canceled.
Yeah, I could. Yes, we could have done that. Thank you. So s equal to 3 gives me b times what? 0 equal to 2b, right? I'm just trying to finish my thought here. So yeah, apparently b equals to 3, which shows that I could have been like not a dummy and instead done like this, right? Duh. So yeah, watch out for that. Oh well. Let's see here. So in summary, y is equal to, what we got? Minus 1 over s minus 1. So little y, inverse Laplace transform of minus 1 over s minus 1, also known as what? Yeah, minus e to the t. So there you go. That's the y. All right. So at this point, how do we find x? We can go back to the blue circled equation, right? So big X is equal to 1 plus s minus 2 times y, which in this context is 1 plus s minus 2 times what? 3 minus s. I'm going to do s minus 3 and pull out a minus if you guys don't mind. It just seems more friendly. Oh, I'm a dummy. What did we just figure out? What did we just figure out? What was y equal to? Don't be a, yeah, don't, so like actually pay attention to that. So we have s minus 2 over s minus 1. Don't be like me. I keep trying to like undo the algebra we just did, which is, you know, dumb. All right, so that's great, but we can do better. We need to make a common denominator here. Or do we? No, we don't. What we need to do is some algebra. This is 1 minus, that's s minus 1 over s minus 1 minus 1 over s minus 1. I'll tell you what, I'm going to, well, and I don't know, if you understand it, you understand it, I guess. But the point is that that cancels, and you're just left with what? 1 over s minus 1, right? If I haven't made a stupid mistake again. And therefore, little x of t equals to what? Inverse Laplace transform of 1 over s minus 1, also known as e to the t. So our solution is x of t equals to minus, e to the t. Y of t equals minus e to the t. I'm a little worried to check this. It does satisfy the initial conditions. That's a good sign. X of 0 is 1. And y of 0 is minus 1. Is dx dt 2x plus, I mean, is it true? Does dx dt equal to 2x plus y? Is it true that dy dt is equal to 2, wait a minute, did I say x plus 2y? So dx dt is e to the t. 2e to the t minus e to the t, yep. Minus 1, yep. We solved it. Hooray. Not an eigenvector in sight, right?
I like eigenvectors.
Oh, okay. Don't worry. I will ask on the final, solve via the method of eigenvectors or solve via the method of Laplace transforms. Or, who knows, maybe there'll be a question where I just leave it open. You could do either one. I do want you to learn both. All right, I guess now that there's still time left, I have to solve the problem that for some reason is, so this problem has given you guys consternation, huh? I'm a little worried. 49, huh? All right, I don't know. So we've got x squared plus 4 times y prime prime plus 1 over x minus 4 y prime plus y equals to 0. And you're supposed to find what is open interval of convergence centered about x equals to 1. And then you're supposed to find the quadratic, the solution to quadratic order at that point. So the first question really is just a question to locate the singularities of this differential equation. And so probably to see that most clearly, we need to rewrite the differential equation like this: y prime prime plus 1 over x squared plus 4 times x minus 4 y prime 1 over x squared plus 4 times y is equal to 0, right? So this has singularities where at x such that either x squared plus 4 is equal to 0 or x minus 4 is equal to 0. So we get a real singularity at 4, and we get complex singularities at plus or minus 2i. As we discussed, you have to consider both in order to understand domains, because like it or not, real problems extend to complex problems, and the theory is completed in the complex domain. And as such, we have to draw the complex plane, like so. We've got a singularity at 2i, at minus 2i, and there's another one over here at 4. We're asked to find a solution that's centered at 1. So that defines the disk, the center of the disk of convergence. There's always a disk of convergence because you always can define, given a center point, you can always find a circle in the complex plane up to the next singularity, right, if there is one. If there is no singularity, then the domain of the solution is the whole real axis. But in this case, well, I don't know, we have to check, you know, I don't know, is my picture honest? So there's the question is like, what's the distance between 1 and 4? The absolute value of 4 minus 1 is 3, right? What's the absolute value of 4, rather 1? How about this? 2i minus 1, that's the distance. This is the distance between 2i and 1. So like in terms of, maybe you don't look at it in terms of this complex notation, that's fine. We should all agree that the distance between 2i and 1 can be calculated from the square root of 4 minus plus 1 rather, right? Because this distance, let me just use another color. This is probably not the part you guys are most squeamish about, right? Maybe? It's more the finding the solution part? No? So this is 2, this is 1. So we 4 plus 1, so square root of 5. Now square root of 5 is definitely less than 3, right? So that means that the complex singularities are the closest ones, and as such, the disk of convergence looks something like this. Right? And so like the radius of the disk of convergence is square root of 5. So the open interval of convergence is, it goes from 1 minus the square root of 5 to 1 plus the square root of 5. That's the answer to the first part of the question, all right? Now, to actually find the solution centered at 1, that's going to take me a minute. Let's see here. So, as a general point of order, if you want to do that kind of thing, you probably want the expressions in the problem to be formatted in the you know, with a center of 1 maybe. I'm not sure what's the most efficient path here? Let's look at it. So we've got, I guess I'll leave it like, I guess I'll do this. It's probably better to leave it. It's probably better to try to solve this one than the other one. I don't know. Sure, what's the best path here? All right. So, sidebar. How do we recenter x squared plus 4 at 1? What I would do is just call this g of, here's probably the fastest way. G of x, this is g of x, right? And that's g of 1 plus g prime of 1 times x minus 1 plus g prime prime of 1 over 2 times x minus 1 squared, right? So like x squared plus 4 is actually equal to, x minus 1 squared, 2x plus 2 times x minus 1 plus, I think, 5. And you can FOIL that out and see that it works. X squared minus 2x plus 2x cancels. I get a plus 1. I get a minus 2. I get a 6 minus 2, which is 4. Yeah. So that's that. On the other hand, the 1 over x minus 4, that feels like a geometric kind of thing. So what I would do there, I'd probably do 1 over 4, well, just a second here. 1 over x minus 1, I'm changing that to x minus 1 minus 3, like that. And then, because I want it to be centered at 1. Then I factor the 3 out, probably, minus 3 actually. That gives me 1 minus 1/3 times x minus 1, which is minus 1/3 times 1 plus 1/3 times x minus 1 plus 1/9 x minus 1 squared. All right. So that's how I would expand those two terms about the center 1. I want to do that because that's just going to make things easier to calculate when I get to the actual problem here. So, all right, so what I have then is I've got, I'm not sure if I should write these out in here yet. I think probably one other step before I put it all together is we're looking for the solution y equals to like a0 plus a1 times x minus 1 plus a2 times x minus 2 squared, right? That's the quadratic order. Why did I put a 2 there? No good reason. Just 1. All right, so we put this all together basically. So I've got x minus 1 squared plus twice times x minus 1 plus 5. That's the whole story. No approximation there. Times y prime prime. What is y prime prime? Y prime prime is what? It's 2a2, right? And what would the next thing? Well, we don't care. Okay? I don't think we care. So we'll just stick with that. Hopefully that'll be enough. If I have to come back and do more here, I'll do it. But I'm just going to start with that. That's the first term. The next term is what? This business, right? Minus 1/3 times 1 plus 1/3 x minus 1 plus 1/9 x minus 1 squared plus dot 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 dot. That times what? Y prime, right? What is y prime? Y prime is a1 plus 2a2 times x minus 1. I guess I need the next term. 3a3 times x minus 1 squared plus dot 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 dot, right? And then finally I've got, that's this term. And then finally I've got what remains, which is what? Y. So plus a naught plus a1 times x minus 1 plus a2 times x minus 1 squared plus dot 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 equals to 0. Now I just need to equate coefficients and I can figure it out. The question is, as we look at the constant terms on both sides, is there a, like, what's the constant term? That would be the first thing to start with, constant terms. From all this, I get a 10a2. From all this, I get a minus 1/3 times a1. I think that's that for that, plus a0. Interesting. From the x term, what do we get? X minus 1 rather term. We get a 4, a2, yeah. And okay, here I gotta be careful. I get a minus 2/3 a2 from this times that, but I also get a plus 1/3. Oh, my bad, minus 1/9, right? A1, let me be careful. 1 times 2 times 2/3, that's a minus. And then minus 2/9. Wait a minute. No, minus 1/9. Yeah. And then over there, what? Plus a1. Did I tell us anything else about this problem? Centered about 1. Let's see here. So, interesting. So a2 is equal to a1 over 3 minus a0, all divided by 10, right? But else it's also equal to what? Oh, my bad. What's 4 minus 2/3? 10/3? Yeah. Okay. So we've got 10/3 a2 equal to what? 1/9 a1. What's 1 minus 1/9? That's 8/9, right? So minus 8/9 a1. This says that a2 is 20 minus 24 over 90 a1. Interesting. So that means this is equal to minus 24 over 90 a1. I think I'm just about out of class time, unfortunately. Yeah, I'm just about. I would conjecture that this implies that a1 is equal to 0, most likely. If I had to guess. And then if that's true, and so I'm gonna put a question mark here. I'm not absolutely certain about that, but that would be my suspicion. If that's the case, then we get y is equal to, you know, a0 times 1 minus 1/10 times x minus 1 squared. Yeah. See, because this says a2 is then just, oh, wait a minute, that would say a2 is 0. That's not good. Hey, you know what? It's very possible that the second order, the solution is just this. Anyway, this problem maybe has problems. You know, just because you can write down a differential equation doesn't mean that it's necessarily a nice one to solve. I do have a quiz for you guys. Let's see here. This one is due Wednesday. So here you go. So lest you